Hello everyone. Today, we're diving into one of the strangest and most profound ideas in modern physics: string theory and higher dimensions. At the subatomic level, if you've ever imagined matter being made up of tiny, point-like particles like electrons or quarks, get ready to shift your perspective. String theory proposes that instead of being zero-dimensional points, fundamental particles are actually tiny, vibrating strings. These strings occupy space. They're not just abstract ideas. And if these strings are real, it means there must be more dimensions than the three we experience. But where are those extra dimensions? What do they look like? And why can't we perceive them? Before we go further, let's understand our three-dimensional world. If you're standing in a room, you can move. Forward or backward, z-axis. Left or right, x-axis. Up or down, y-axis. These are the three spatial dimensions we live in. But any movement, no matter how small, requires time. Even doing nothing still requires time to exist. That's why time is considered the fourth dimension, inseparable from space. Together, they form what Einstein called space-time. In 1919, a relatively unknown German mathematician named Theodor Kaluza proposed something bold. What if the universe had 5 dimensions? By adding a fifth spatial dimension, he found that Einstein's equations for gravity and Maxwell's equations for electromagnetism could be combined into a single unified equation. Even Einstein was skeptical at first, but after 2 years, he admitted, "Previously, I did not fully understand your idea. If you wish, I will present it to the Academy of Sciences myself." This marked the first time humanity seriously considered a fifth dimension. Kaluza's theory was far ahead of its time and was largely forgotten until the 1960s and 1970s, when physics hit a major milestone: the creation of the Standard Model, which successfully described 3 of the 4 fundamental forces: electromagnetism, weak nuclear force, strong nuclear force. But it couldn't explain gravity. Every attempt to include gravity led to contradictions or meaningless results. So physicists started to revisit the idea. What if the universe has more than 3 spatial dimensions? Each time they added a dimension, the math became more stable, the forces interacted more coherently, and paradoxes began to dissolve. To understand what hidden dimensions might be like, imagine this. You stretch a drinking straw across a glass and place an ant on it. From a distance, the ant seems to walk on a one-dimensional line. But zoom in, and you see the straw is cylindrical. The ant can also move around it. Those extra directions were always there, just too small to notice. Physicists imagine extra dimensions as curled up within space, too tiny to observe. These are modeled using Calabi-Yau manifolds' geometric shapes, representing how extra dimensions are compactified at every point in space. And as strings vibrate, they can move through these hidden dimensions even though we can't see them. One of the biggest challenges in quantum mechanics, especially for point particles, is the problem of negative probability. Probability should never be negative, but when modeling point particles, some equations produce nonsensical results. String theory solves this. By treating particles as vibrating strings in 10 dimensions, 9 space plus 1 time, all negative probabilities vanish. The math becomes consistent and stable. More dimensions give strings more ways to vibrate, absorbing mathematical instabilities. That's why string theory insists on exactly 10 dimensions, not more, not less. So if string theory is correct, our universe isn't just 3D. It's actually 10-dimensional, 3 familiar spatial dimensions, 1 time dimension, and 6 extra dimensions curled up too tightly for us to perceive. Whenever you move through space, you're also moving through those hidden dimensions. though you don't feel it. In summary, string theory gives us a radically new view of reality, a multi-dimensional web where strings create all particles and forces. And just because we can't sense those dimensions doesn't mean they aren't there. If you found this video interesting and easy to understand, let me know by leaving a comment. Do you believe in a 10-dimensional universe? Or is it still just an abstract theory to you? Like, subscribe, and hit the bell to explore more on M-theory, the multiverse, and the deepest layers of reality. Thank you for watching. See you in the next video.